Okay, so the first examples that we're seeing here concerning sequences are, I'm starting off kind of gentle. I described to you what an arithmetic sequence is. It does look like the word arithmetic. Whenever it's used as an adjective, it's not pronounced as arithmetic, it's pronounced as arithmetic. So I described to you what an arithmetic sequence was, a sequence in which there is a constant difference d between a set of successive terms. So everywhere you look on an arithmetic sequence, from one term to the next, whatever it is you add or subtract in going from that first term to the next, that will be constant. It will always be the same. The way you go about finding the constant difference in any arithmetic sequence is you take one term and you subtract the previous term. If you can remember at some point in your life learning the definition of a difference, it's always the new value minus the old value. If I tell you the difference in my weight from this year to last year is 10, does that mean I gained 10 pounds or lost 10 pounds? Well, if you take the new value minus the old value and get 10, the only way to get 10 is if the new value is 10 more. So, for instance, if this year I weighed 230 pounds and last year I weighed 220, that difference in weight would be 10. Whereas, if I said, this year I weighed 220, last year I weighed 230, the new value minus the old value, the 220 is the new value this year, the last year's value, 230, you get a difference of negative 10. So, that, if I said, what's the difference in my weight? This year I weighed 220, last year I weighed 230, you would say the difference is negative 10, which shows a loss of 10 pounds. So, new minus old, that's how you're going to find difference. So, for the first three examples here, you have to find the next three terms. If you're having trouble finding the constant difference, use that method I said. Choose any term and subtract. This would be the newer term, this would be the older term. This would be the newer term, that would be the older term. It doesn't matter which way you do it. So if I use those two, I'll do negative 28 minus negative 21. Change that to addition, I'll get a difference of negative 7, which I would imagine you could probably tell that's what was going on. Subtract 7, subtract 7, subtract 7. But here our constant difference is negative 7 because we're subtracting 7. So to get the rest of them, you subtract 7 from this, you'll get negative 35. You subtract 7 from that, you'll get negative 42. You subtract 7 from that, and you'll get negative 49, which is what that third term will be. So the next example, we have to find the next three terms. You probably have already done the calculation in your head to see that the difference between these, any term and its previous term, 12 minus 0 is 12, or 24 minus 12 is 12, or 0 minus negative 12 is going to be 0 plus 12, which is 12. So that's what we're adding on each time, that constant difference to get from the previous term to the new term. So this would be 36, we'll add 12 to that, we'll get 48, we'll add 12 to that, and we'll get 60. Now, I'm going to ask, if this sequence is a sub n, if I say this sequence here is a sub n, how could we use that sequence notation to say the 1, 2, 3, 4, 5, 6, 7th term is 60? How do you say the 7th term of the sequence A is 60? If you remember from before, you'll say a sub 7 is 60. That's all. The 7th term of the sequence A is 60. Alright, so this last example, I want the next three terms. You have to find the constant difference. I would suspect that many of you are going to use these two, first minus, or newest minus older term. And you'll see that your constant difference here is 0.4. So that means to get from one term to the next, you're adding 0.4. So add 0.4, you'll get 1.8. Add 0.4, you'll get 2.2. Add 0.4, you'll get 2.6. New term minus old term is the constant difference. That's how we do it.